In a figure P, P is a point on the curve y equals x squared. Happy days. Prove that the curve divides the rectangle OPN in two regions whose areas are 2 and 1. Wow. Alright, do you know what that's telling me? It's telling me it doesn't matter what size the rectangle is, it's always going to hit in the same ratio. Do you get what I'm saying? So, what I'm trying to say is that if I did a bigger rectangle, like up here, and it hits the line and comes down, I think what it's saying is no matter what, it's always in a 2 to 1 ratio. Does that make sense? So it doesn't matter what x value I pick. But for argument's sake, I'm just going to use x. Is that okay with you guys? So can this point be the point x0? Is that okay with you guys? And this is the point what? It'd be 0x squared, wouldn't it? Because y equals x squared, so that's 0x squared. Okay? And if I'm being really lazy about it, which I can be, I can say the area of the rectangle is what? What's the area of the rectangle then? If that's x squared up and that's x across, what's the area of the rectangle? X cubed. Yeah, I'll settle for that. I'll use it in a second, don't worry, I'll use that information in a second. So we're going to go for that being x cubed. Who got that far? Right, hooray. Alright. Sometimes you need to use the solutions, lads. You just need to have a look and try and figure it out. I do it all the time. If I forget how to do a question, I have a look at the solutions until I figure it out. Right? It's better than doing nothing. It's better than doing nothing. Alright. Now, everybody happy that's x cubed? Alright, next one. I'm going to get this area here. Anybody tell me how I'm going to get the yellow area? Any takers? The integral of 0 to x of x squared dx. Okay, no worries. And then I'm going to get 1/3 x cubed from x to 0, and that equals 1/3 x cubed. Everybody happy that's 1/3 x cubed? What does that make the other area then? Because it has to add up to give you x cubed. That will make this area 2/3 x cubed. And therefore, what would be the area? What would be the ratio of the green area compared to the yellow area? 2 is to 1. You can say 2/3 x cubed is to 1/3 x cubed, and that is a ratio of 2 is to 1. Wasn't too bad in the end, was it? No, wasn't too bad. Right. Let's keep going. Alright, this one. Oh wait, shouldn't have done that. There you go. Is that all of it, is it? Alright, y equals x to the power of a half. Prove it that the area of the shaded region is 2/3 the area of the rectangle. No bother. What point is this we're going for? x0 and this one here? 0x to the power of a half. So what's the length and the width of that rectangle then? What do you reckon? X to the power of a half and x. And what is x multiplied by x to the power of a half? X to the power of 3/2 for the area. Is that okay? Now, how do we get the area of, call it B, area B? Yeah. So the integral of 0 to x to the power of a half dx, and this is should be reasonably easy. Add 1 onto the power, Carl, what you get? Turn that power upside down. 2/3 x to the power 3/2 from x to 0. Now, oh yeah, we're grand. First part is it's going to stay as 2/3 x to 3/2. and then it's going to be minus 0, isn't it? So this here is the answer. Now, what's the answer for the actual rectangle as a whole? The actual answer for the rectangle as a whole is x power 3 over 2. So the area of the shaded region divided by the area of the actual rectangle, and the x to the power 3 over 2 is cancelled, leaving you 2 over 3. Now, for the curve y equals x to the power of n, P is a point on the curve where PM and Pn are perpendiculars from P to the x-axis and the y-axis respectively. Okie dokie. Does it say n has to be positive or anything like that? No. N can be pretty much any value it wants to be, can't it? So what did we already do earlier? We did x squared, which is a curve like that, wasn't it? We did x, was it x cubed, was it? X power of a half, which is a curve like that. So the bottom line is, I don't know where it crosses the y-axis, do I? If you get what I'm saying, I don't know if n is down here. And P, where's P? P is a point on the curve. So imagine that's point P. Right? I don't know if n is at 0, 0, or I don't know if n is, oh sorry, n is the y-axis one, excuse me. I don't know if m is at 0, 0. I don't know if m is over here. I don't know if n is at 0, 0, or n is up here. I actually have no idea. Right, that's the first thing. Everybody cool with that? I'm going to assume they're both away from the... Sorry. 1 second. Alright. Now, for argument's sake, lads, I'm just going to go with something I can visualize. I'm going to go with n and m up here somewhere. Okay? So it says they're perpendiculars. PM and Pn are perpendiculars from P to the x-axis and P... Oh, sorry. I see it now. 1 second. So, I'm going to draw a random curve. Any random curve. Right? I'm going to put P here. You okay with that? Now P is up here. Then we're going to go directly down, isn't it? P and M perpendiculars from P to the x-axis. There you are, there. And P to the y-axis, which is P to... There we go. Which one's N? Which one's M? Which one's N? Good man. And this one? M. Right. We're good so far. Right. Next thing. We're going to pick a point for M. For argument's sake, I'll call it K0. I could also call it X0 if I wanted. Now, if K is the X value, what's the Y value? K to the power of N. So would everybody happy with this being called K to the power of N? Yes, Mick.
Just a question. Because it says enclosed between PM, the x-axis, and the curve. Would you not know it the way you have the curve?
Do I know the curve's this way?
Yeah, would you not know it?
If I wrote it like that, still roughly the same, isn't it? So it would be. I'm not going to think too much about the curve. I'm just going to draw it one way or the other way, and I'm just going to figure out. All right. Now, where was I? Okay. Prove the area of the region enclosed between PM, x-axis, is equal to 1 over n plus 1, the area of the rectangle. Okay. First thing we're going to do is find out the area of that rectangle. What's the area of the rectangle, Gaffigan? How far is it from here to here? K for this one. It was X in the other ones. How high is it, Gaffigan? In this case, it's K to the power of N. So that's 0, K to the power of N. Now, Connor, we're going to multiply the two of these to get the area. So what's the area of the rectangle? What's Kn multiplied by K1? You add them together to get? K. kn plus 1. You add the powers together. In the same way, k2 by k3 is k2 plus 3, which is k5. Is that right? Now, what we're going to do next is we have the area of the rectangle, don't we? Next thing we do is go and get the area of the curve. Doesn't matter which way that curve pins itself against the x-axis. It could have pinned itself in that way. It doesn't matter, right? It's part of it is going to be pinned into the x-axis. That's the main thing, okay? Now, what we're going to do next is we're going to find out the area of this. So, it's the integral of what, guys? 0 to, would you agree with 0 to k? What's the y value? X to the power of n, and then dx. And what do we get here? What happens when you integrate? What do you do with the power? Add 1 on. So what happens when you add 1 on? You divide by the new power, which is? And you integrate from k to 0. So anywhere you see an x, replace it with k. So what you get? Kn plus 1 over n plus 1 minus 0. Factorize out. What do you factorize out? What is it? Alright. Now, as I was saying, is we're just going to take out the fraction. It's going to be 1 over n plus 1 times kn plus 1. Now, we have to figure out what fraction that is of the original rectangle. So if we divide by the original rectangle's area, which is kn plus 1, what happens? Cancel, and the answer is 1 over n plus 1, and that is what you were asked for. Alright, that is tough, and I can understand when it gets all those letters, it gets very frustrating and you haven't got a clue what's going on. Alright, so just to recap on Michael's point earlier, that if I drew the graph like this, with any other curve I wanted, so if I drew it sort of like that, hitting the axis, I said that's the point P, right? And would that be the rectangle, wouldn't it? Now, Michael is correct in that regards, that if we were to do the area underneath that, it would be bigger than the actual rectangle, wouldn't it? So he was right that it has to be curving away, because he recognised that it was curving away, because if you do it the other way, like this, and you're curving away like so, in this case the rectangle is clearly bigger than the area under the curve, so it had to be that way. He was right. Just couldn't process it at the time. Now, let's move on. We all good? 6. Okay. Now, look at this beautiful equation. Now, here's what I'm going to do. Being the lazy man I am, here's what we're going to do. We're going to go to table function, and we're going to do x squared over 1000, is it? Over a g. 50 minus x. What do you reckon? Go up in tens. Go up in tens from. Actually, I'll go up in fives from 0 to 50. How about that? Start at 0, end at 50. Go up in fives. Not doing anything that's rocket science at the moment. This is pure easy. What am I asked for? X equals. I'm asked for x equals 10 and x equals 40. X equals 10 is an answer of 4. X equals 40 is an answer of 16. So that's 16. And that's 4. Everybody cool with that? You just sub in the numbers into the original equation. Right, it's very easy. Find the slope of the boundary curve when x equals 10 and x equals 40. Right, Oscar, how do you get slope from our original equation. The first derivative, good man. Is there any way to make that a bit easier on myself? What would be a good idea?
Put 50 over x to put that out of the bracket as well.
Yeah. If I multiply it in, what do I get? Just multiply it in.
50 over 10 is x squared minus x cubed over 10.
Yeah, 50 over 1000 x squared and minus
Cubed
over.
1000.
Perfect. Now I can differentiate that, alright? It should work out okay. So I'm going to differentiate x squared. What you get? You
3x.
2x for that one, yeah?
Yeah. Okay.
And what's 2x multiplied by 50?
100x.
So it's going to be 100x over 1000. I'll get to that in a second. Ben, what do you reckon about the derivative of x cubed?
Probably 3x squared over 10.
Yeah, here you go, yeah. Very good. Now, this formula here will give you the slope of anything you want at any time. It will tell you if the equation is increasing or decreasing. Whether your equation is on its way up, it'll be a positive answer, or when it's on its way down, it will be a negative answer. Matthew, make a prediction. When we plug in x equals 40, are we expecting a positive or negative answer?
Negative.
And for x equals 10?
Positive.
Okay. And if this matches what we're talking about, it should work that way. Now, once again, I'm going to be a bit lazy. Okay, I'm going to come in here, and I'm going to do 100x divided by 1000. Right, I'm not even bothering with the diminishing it down or anything like that. I don't have to. Well, hey. Now, and then minus 3x squared, is it? Oh, Jesus. All over 1000. Now, I only need, what do I need? 10 and 40 again, isn't it? Substitute in 10, substitute in 40. The answer for 10 is 0.7. So at x equals 10, dy dx equals 0.7. That means 0.7 going upwards, it's increasing. And then at x equals 40, we're expecting a negative answer, aren't we? Because it's clearly on its way down. Let's go, 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 go. Excellent. Minus 0.8 or 4/5. So your prediction works there, that you knew it was on its way down and you knew what answers you should have been expecting. We all good? Alright. Is there a C part to this? Oh man. Loving this. Now, find the value for x which the height amount is maximum. Alright. Oscar, what's the rule for maximum?
The slope is 0.
Right, and if the slope is 0, what does that mean? First derivative has to equal 0. So let's go back to the first derivative. We had it here, didn't we? Alright. Now, back to my favourite. Gaffer, what would you do here? What about the 1000? What do you think? Multiply everything by 1000. And 0 times 1000? Exactly. Now you're in business, alright? You're nearly there. Okay. What do you think you're going to do next?
Take away x.
And you get?
100
Okay. What then?
x equals 0.
Yep.
100 minus 3x equals 0.
Yeah.
3x equals 100.
Yeah.
X equals 100 over 3.
Yeah, which is roughly 33, isn't it? Now you can look back up on your graph. Is the maximum roughly at 33? It is, isn't it? So we're actually quite happy with that answer. It's exactly where we're expecting it to be. Who got that part out? Alright, easy money. Good man.
Why do you have multiple there?
Find its maximum height. Oh dear, right? So what does that mean? Go to your original equation and substitute in 100 over 3. So one of you guys going to spare me the misery? Somebody reliable?
18 for 5, 2,007.
So somebody reliable?
500 over
Any reliable person whatsoever?
500 over 27.
There we go. Anyone at all? Sorry, what did you get again, Michael, out loud?
500 over 27.
500 over 27. Jamie Oliver, is that alright? Yeah. We have a famous cook in our class, it's Grant. No. Shocking. 500 over 27. Now go and make me a casserole. Now, find the cross-sectional area of the mound. Lads, is the mound this part here? I'm going to reread the actual description of the question. Alright, the mound is actually the full thing. Yeah? So, we're going to have to integrate that, aren't we? So I'll just go back here. I'm not using this stuff anymore anyway. So I want you to find the area of this. Alright, Charlie, what formula do I use?
Integration.
Yes, Charlie. What number should I use?
Y is equal to x squared over 1,000 minus x.
We're going to use that thing.
From 0 to 50.
50x squared divided by 1,000 is, what's 50 over 1,000? 1 over 20. So did everybody agree with x squared over 20? And then, what's the x cubed over 1,000? Alright. What number should I put here, Charlie?
0 to 50.
0 to 50. Alright, now, anyways. Alright. Integrated Barry. Once we integrate x squared. 3 times 20, yeah. Which is 60. Grand. And the next one? Over 4 grand, yeah. 4G. 50 and 0, as they say in the streets. Now, what next? Yeah, would somebody save me the misery?
500
Anybody at all?
Sir, I got this right.
God's sake. Oliver, call it out. What is right? What number? 523.
520.83.
That's got to be wrong somehow. Now, no, alright, it's good. 520.83. Alright, guys. Now, done. 520.83. 520.83. Nice one, Daly. Now, alright, guys. The top of the mound is removed as shown. The point has a coordinate 20 and 12. Oh, are they really doing that to us? That's awful. Alright, here's what they're doing to us. We know that the y coordinate is 12, don't we? So, what's the original equation? Anybody, what's the original equation?
1 over 20 x squared.
So x squared over 20 and x cubed over 1,000. Yeah, this is pure mean. X squared over 20 and... Awesome. This is why they're extended response. This is like what you get in section B of the Leaving Cert. Really long, goes parts E, F and G. You're in a true battle with the question, okay? Now, lads, here's our original equation. And the only thing we know is that we're guaranteed a we're guaranteed a 12, aren't we, for the y value? Right? Now this gets a bit difficult here, right? So we put in 12 for y, and now we get x squared minus 20 minus over 1,000, right? Now we're going to have to give it a common denominator. What's the common denominator? 1,000, right? So this is 12,000 here. Like 12,000. 50 and that's 50 times, is it, for 20? 50x squared. And then here, just x cubed, isn't it? Now, here's the fun part. Anybody remember chapter 1 in 5th year? How did you actually get the factors of this? Yeah, you're actually going to have to go through the whole, like, there's no x, is there? There's no x value, but we'll get to that in a second. And you're going to go plus 12,000. And what you're going to have to do is you're going to have to do trial and error to find what x value actually causes that to be equal to 0. Now, what we promised ourselves was this though, didn't we? We sort of said, look, we'll just use the table function. And we figure it out that way, won't we?
You already have a value. Because
Oh, we already have a value, do we?
Yep,
Ah, lovely. So we pay you the money. Right? We already know x equals 20 is a factor, don't we? Now, if we weren't sure, sub in 20, it will work. Okay? So we know x equals 20 is a factor. So, sorry, x equals 20 is a root. What does that mean as a factor? Fail. Anybody at all? No. Alright. X minus 20 equals 0 is a factor, okay? So we do x minus 20 and we long divide that in. That's known as the factor term. If you have a root, bring the root over to the other side, and then you have a factor, something that will divide into the original. Now, I'm going to put in 0x here, haven't I? See, this extended response question this question has everything in it, doesn't it? Differentiation, maximums, functions. Like, this is the sort of question that would be very useful in a test, like for you guys. Like, to be honest, has tests everything. Now, x cubed is 20x squared. That's it, really, isn't it? Then press plus, turn minus and a plus. Zero x. Now what do we get here then? Minus 30. Plus 600. Plus minus 600. X plus 12,000. Divide it in again. Minus 600. Alright, and what do we get then? Yeah, we do get 0. Alrighty. Now, you think you're done, don't you? No, you're not. We're so not done. Factorize that. Somebody just give me the answer, put me out of my misery here. What are the two factors?
X equals minus 13.72.
Oh, it doesn't even go in evenly. It's a minus b.
Yeah.
Alright, this is a minus b. I'm not doing the minus b for the sake of us all. A is 1, b is minus 30, minus b is plus 30, c is 600. We're expecting to answer. Yes, it is, Mick. That's why we pay the big money. Now, we're expecting to answer somewhere between 40 and 45. What answer does the minus b formula give you a fail on?
43.72.
That's why we pay you nothing. Now, 43.72. Is everybody happy with me skipping the minus b for all our sanity? Excellent. Good work. Now, are they actually going to ask us to get the area of the new part? Oh, God. Is that it?
No.
find the values of A. Find the values of A, B, and R so that the area of the top of the mound to be removed is given by this. All right. We're okay. I got it. Lads, what does everybody think R stands for? I think it stands for rectangle, and I'll explain why. If I integrate this, lads, stop being distracted there at this stage, right? It gets tough. Alright? So, sorry, it's 40, sorry, what did you say it was earlier? 43.72, sorry. So this point here is 43.72 and 12, okay? Now, what I'm trying to tell you here is that if I integrate this from 43.72 back to 20, what area do I get? Anybody? Would everybody agree I got that green area there? Everybody agreed? What happens if I take away the area of the rectangle? What will be left over? If I take away the area of the rectangle, you'd be only left with the area on the top. Next thing, what is the height of that rectangle? 12. What is the length of that rectangle? 20 up to 43, which would be 23.72. Multiply 12 by 23.72 and you get the area of your 284.64. So the R value is 284.64. Is everybody agreed with that? Alright, and what's the A and B value? Yeah. 20 and 43.72. When you multiply 23.72 and you multiply it by 12, 284.64 for me.
Because you rounded it previously.
I rounded to 43.72. Alright, so there might be small discrepancies in your answer. Michael, who has a more accurate round off, is saying that that's 284.67. That's okay. So your answer should be okay. Sometimes you round off and you miss out by 0.03. That's alright as well. Right, we good? Alright.